Good morning, students. Exercise 9.8, ninth problem. The curve y is equal to x minus 2 the whole squared plus 1 has a minimum point at P. A point Q on the curve is such that the slope of PQ is 2. Find the area bounded by the curve and the chord PQ. Okay, you see that only one curve is given and it is given that it has a minimum point at P. Okay, first you have to draw the diagram. So before diagram, we'll find out what is the minimum point. So you take the curve and how to find the minimum. So you have studied in differential calculus using the second derivative how to find the minimum. So the procedure is maximum point and the minimum point. So that is first one you have to find the first derivative. On the next one, first derivative is equal to 0. You will get some points. So and you have to go for second derivative. Substitute the point at which first derivative is equal to 0 in the second derivative. If it is greater than 0 means the function or the curve has a minimum point at that point. Okay, if the second derivative is less than 0 means the curve has a maximum at that point. Okay, so I'll consider the curve. It is given that this curve has a minimum point at P. So the P coordinate, what it is, we are going to find. So first you have to take the first derivative of this. So if you differentiate y with respect to x, that is y dash I have mentioned. So it is x minus 2 the whole square. First you just consider x minus 2 as x. It is in the form of x squared. So your answer is 2x minus 2. And x minus 2, if you differentiate, the differentiation of x is 1 and minus 2 is 0. So you will get 2 into x minus 2 for the first term. Here plus 1 is a constant, so it will become 0, whose differentiation is 0. Next step, what you have to do, the first derivative is equal to 0. So 2 into x minus 2 is equal to 0 means 2, here x minus 2 is equal to 0 by 2, that is 0, x is equal to 2. So you get a point. Okay, next you have to find the second derivative. Go to the first derivative, differentiate it again with respect to x. So here 2 is a constant. X if you differentiate it is 1 and here minus 2 if you differentiate it is 0. So 2 into 1 minus 0. So it is 1 minus 0 was 1. So 2 into 1 is 2. So what you have to do? You have to substitute this point in the second derivative. So here the constant is there. So you will get the same answer 2. So how is your 2? It is greater than 0. If greater than comes, the curve has a minimum point at x is equal to 2. So this minimum point is occurring when x is equal to 2. And you have to find what the point is. So you need y. So x equal to 2 has to be substituted in this place. So 2 minus 2, what it is? 0. 0 squared is 0. 0 plus 1. So y is equal to 1. So you have obtained the minimum point is 2, 1. Now we'll come for the diagram. So minimum point, you know that what is it? It is 2, 1. You see, as usual, we have to consider the what is it? This 1 or 2 points or more than 3 points to draw the curve. So first I will substitute x as 0. X 0 if you substitute it is minus 2 the whole square, that is 4. 4 plus 1. So 0, 5. Next step what I said, you have to substitute y as 0. You see that when you substitute in this curve y as 0, 0 is equal to, what has to come? X minus 2 the whole square plus 1. So on the plus 1, when you take it to the next side, it is minus 1 is equal to x minus 2 the whole square. So if you expand, it is minus 1. Otherwise x minus 2 if you want to find, it is nothing but square root of plus or minus 1. So within the square root you will have minus 1. So it is a imaginary. So when y is equal to 0, and that is the curve is imaginary. So I then substitute y as 0. So then I'll give some values for x. So put x is equal to 1. So 1 minus 2 is minus 1. Minus 1 the whole square is 1. 1 plus 1 is 2. And x is equal to minus 1 if you substitute, minus 3 the whole square, that is 9 plus 1 is 10. When x is equal to 2, 2 minus 2 is 0. So here it is 1. X is equal to minus 2, minus 4 the whole square, that is 16 plus 1, 17. In this way, if you want, you can find out 3, 4 like that. Okay, so I'm going to substitute, mark the points 0, 5. So this point is marked 0. It is 0, 0. So 0, 5. So here I have taken 2 units because y value up to 17 is there. So 1 unit is equal to 2. So it is 2, 4, 6, 8, 10, 12, 14, 16, 17 like that I have marked. So it is 0, 5 I have marked here. And 1, 2. So 1, 2. Next one, minus 1, 10. So here this point. So this point and here 0, 5 and 1, 2. The next one I have marked 2, 1. So this is 2. X value is 2. And here in between you will have 1. Okay, so this point 2, 1. So we have said it's a minimum point. So I marked this as P because it is given this curve has a minimum point at P. So the minimum point is 2, 1. So 2, 1 I named as P. Okay, so join these points. Okay, up to this I have joined. Okay, after that I need I have to draw the curve. So for that you would substitute x is equal to 3. 3 minus 2 is what? 1. 1 squared is 1. 1 plus 1. So 3, 2. So it is marked here. Next one. If you substitute 4, 4 minus 2. 4 minus 2 is what? 2. 2 the whole square is 4. 4 plus 1. So this is 4, 5. Okay. This is 0, 5 and here you are having 4, 5. So and if you substitute, you can extend the curve. Otherwise you take 5, x as 5. 5 minus 2 is 3. 3 the whole square. What is it? 9. 9 plus 1, 10. So next x is equal to 6 means it will come as 17. So the parabola will be opened upward. Okay, it has a minimum point at 2, 1. It is marked as P. So we have completed. Parabola is completed. What is only one curve is given? I have marked it. Okay, and you see that a point Q on the curve is such that the slope of PQ is 2. So already P is marked. So you have to take the point Q on the curve. Okay, in such a way that this line, the slope of PQ, if we join P and Q, that the chord or the line, if we extend it, so whose slope is 2. So here we have to mark the line or we have to mark the chord PQ. For that you need Q. So we need the equation of the straight line. Okay, PQ. So we need the equation of the straight line PQ. So see now how to find the equation of the straight line PQ. Okay, so what is given? That slope of PQ is 2. So therefore m is equal to 2. Okay, and what is the P point? It is, what is it? The P point is 2, 1. It is the minimum point 2, 1. So you will have one point and the slope is there. M and one point, that is x1, y1 and m is there. So therefore the equation of the line PQ is using the formula y minus y1 is equal to m into x minus x1. So the x1, y1 is 2, 1 and m is equal to 2. If you substitute, y minus 1 is equal to 2 into x minus x1. What is your x1? It is 2. So 2x minus 4. So arrange it. So 2x minus y, and here this minus 1, when you take it to the next side, it is plus 1. So minus 4 plus 1 is minus 3. Okay, otherwise you can take this y, you can keep as it is. This minus 1, when you take it to here, it is plus 1. So 2x minus 3. That also you can take it. So we have found the line also. But what is needed? The point Q is needed. So we have to find the coordinate of Q. Okay, we have to find the coordinate of Q. So see that Q, where it is as well as on the line as well as on the curve. So we have to solve the curve equation and the line equation. So this line equation I have written as y is equal to 2x minus 3. So in the place of y, on this curve you can substitute 2x minus 3. So 2x minus 3 is equal to x minus 2 the whole square plus 1. So when you expand this, it is x squared plus 4 minus 4x, a minus b the whole square plus 1. So x squared minus 4x, and this 2x when you take it to the next side minus 2x. This minus 3 when you bring it here, it is plus 3. So 4 plus 1 is 5. 5 plus 3 is 8. So it is x squared minus 6x plus 8 is equal to 0. So it's a quadratic equation in terms of x. So when you take the product, you have to get 8, and the addition of those two numbers is minus 6. So minus 4 into minus 2 is plus 8, and if you add you will get as minus 6. So you can write x minus 4 into x minus 2 is equal to 0. So you are getting x is equal to 4 and x is equal to 2. X equal to 2 means it's a coordinate of p, because p x coordinate is 2. So we need to find q. So therefore q point is, what is it? X equal to 4. When x equal to 4, if you substitute in this straight line, 4 into 2, what is it? 8 minus 3. What is 8 minus 3? That is 5. So here q point is 4 comma 5. Okay, so we have found the point 4 comma 5. So x is 4 and y is 5. So this point. So we marked, we drawn the chord PQ, and I extend its line. But what is needed? Find the area bounded by the curve and the chord PQ. So the PQ is enough. So this yellow color area only we have to find out. So this is the area bounded between the line and the curve. So two results are there. So what you have to do? You have to find the point of intersection. So we have found the point of intersection and the diagram also drawn. Next you have to choose the axis. So I'll choose the x-axis. So it's varies from P to Q. So P to Q, isn't it? This area we have to find it. Okay, so the limits are x is equal to 2 and x is equal to 4. So the formula is integral 2 to 4, because the lower limit is x has 2 and the upper limit is 4. So integral 2 to 4. Here you have to write about x-axis means you have to choose y dx. Here two curves are there, so therefore it is y1 minus y2 into dx. So now what you have to do? You have to choose y from the first curve. So what is the first curve? How to find it? You have chosen the axis as x-axis. What you have to do? You have to draw any arbitrary line which is parallel to y-axis. So this is the line parallel to y-axis. It will touch first which one? The line. Then after that's only the curve. So the y has to be taken from the line. Y is equal to 2x minus 3. That is called as y1. And y2 is, y has to be taken from the curve. Y is equal to x minus 2 the whole square plus 1. Okay, so here it is 2x minus 3. In between you are having minus. What is your y2? From this you have to take y. So that is x minus 2 the whole square plus 1 into dx. So see that 2x minus 3. The minus when you apply, it is minus x minus 2 the whole square. Minus into plus minus 1. So 2x minus x minus 2 the whole square. What is minus 3 minus 1? That is minus 4. Okay, so you have to integrate 2x, the integration of 2x. 2 is a constant. If you integrate x, it is x squared by 2. So that is written 2 into x squared by 2. The next one, what you have to do? You have to integrate x minus 2 the whole square. So it is in the form of ax plus b the whole square. So you have to write, when you integrate, you have to write the coefficient of x in the denominator. Here the coefficient of x is 1. So no problem, it's a linear function. So when you integrate, it is x minus 2 the whole square. When you integrate, it is x minus 2 the whole cube by 3. Okay, if you have the coefficient of x, it should be in the denominator. And the next one, here minus 4. So it's a constant. If you integrate, it's minus 4x. And you have to apply the limits 2 to 4. So 2 and 2 getting cancelled. So x squared minus x minus 2 the whole cube by 3 minus 4x. Now you are going to apply the upper limit 4. So 4 squared is 16. here you are having 4 minus 2 is 2, 2 cube is 8 by 3. So minus 8 by 3. When you apply in the place of x as 4, 4 4s are 16. So minus 16. In between you have to write minus. So before applying the lower limit. So when you substitute 2, 2 squared is 4 minus 2 minus 2 is 0. 0 by 3 is 0. And 2 into x is, what is it? In the place of x has 2. So 4 2s are 8. So plus 16 and minus 16 getting cancelled. So here you are having minus 8 by 3. And 4 minus 8 is minus 4. So minus into minus plus 4. If you take LCM, it is 12 minus 8. So what is 12 minus 8? That is 4 by 3. So the area between the chord PQ, and the curve is nothing but 4 by 3 square units. So we'll come to the 10th problem. Find the area of the region common to the circle x squared plus y squared is equal to 16 and the parabola y squared is equal to 6x. So first we have to draw the diagram. You see that x-axis, y-axis is drawn and the circle is drawn. So circle center is 0, 0 and the radius is r squared is equal to 16 means r is equal to 4. So this radius is 4 units. OB is 4. So therefore the B point is 4, 0. Okay, circle is drawn with the center 0, 0 and the radius 4 units. Next, the parabola y squared is equal to 6x. So it's a parabola open rightward and it is in the standard form. So I have drawn the parabola open rightward. Okay, so this parabola definitely touches the circle at 2 points. One is C, another one is I marked as A. So area between the circle and the parabola is needed. So the green color part is needed. Okay, so whatever it is, it's a circle and the parabola, two curves. So first you have to find the point of intersection. Okay, so y squared 6x has to be substituted in the circle equation. So x squared plus 6x is equal to 16. So x squared plus 6x minus 16 is equal to 0. When you take the product, it should be minus 16 and the addition is 6x. So 8 into minus 2 is minus 16. 8 minus 2 is 6. So therefore x plus 8, x minus 2 is equal to 0. So x is equal to minus 8 and x is equal to 2. X equal to minus 8, I have written it as x. You see, x is equal to minus 8, I have written it is not possible. Why it's so? You see that in the parabola, if you substitute x as minus, so minus 48. So y squared is equal to minus 48 is y is square root of minus 48. So within the square root you will have minus. So it's a, what is that? It is imaginary. Okay. So see that your parabola is open rightward. So in the negative side of x-axis, the parabola does not exist. So that's why I have said x is equal to minus 8 is not possible. So I have taken x is equal to 2. Okay. So when x is equal to 2, when you substitute y squared is equal to what? 6x. So 6 into 2, that is 12. So it is as y is equal to plus or minus square root of 12. So square root of 4 into 3. Square root of 4 is 2. So it is 2 root 3. So when x is equal to 2, your y is 2 root 3 and next one 2 comma minus 2 root 3. So this is a point 2 comma 2 root 3 and this is the point 2 comma minus 2 root 3. So we have found the point of intersection. We have drawn the diagram. Next you have to choose the axis. So here how we are going to find, due to symmetrical property of parabola as well as the circle. Circle is symmetrical about both the axes, but this parabola is symmetrical about x-axis. So your required area is what? O, A, B, C. So this is the part, the green color part. The green color part we have to find. Due to the symmetrical properties, what we are going to find? First, we are going to find the area OBC, that is which is lies in the first quadrant. What is it? OBC. And you are going to multiply into 2. So therefore, the required area is OABC. But due to the symmetrical properties, it can be written as 2 into area OBC. Okay, this area OBC, that is the numerator part, that is the first quadrant part you are going to find. So this area is divided into two parts. One is from 0 to 2. 0 to 2. Next one from 2 to 4. Okay, see that 0, this is x equal to 0 and this is x equal to 2. And if you draw from this point, if you draw the line, that is x is equal to 4. So 0 to 2, up to this you will have only the parabola curve. And you see that 2 to 4 you will have the circle curve. So the OBC, the area in the first quadrant, it is divided into two parts. One is from the limits 0 to 2. Another one is from the limits 2 to 4. So in 0 to 2, you will have only the parabola curve. So the formula is, you are choosing the x-axis. So only one curve is involved. Only one curve is involved within the limit 0 to 2, that is parabola curve. So therefore integral a to b y dx, that y has to be taken from the parabola equation. Next you have to move from 2 to 4. The limits, that is the lines x is equal to 2 and x is equal to 4. In that limits, or in that within the lines, you will have only the circle curve. So from that you have to take y. So from the circle equation you have to take y for the limit 2 to 4. So see now, this 2, it is twice. So this 2 is written here. So it is 0 to 2 y dx plus 2 to 4 y dx. This y has to be taken from the parabola equation. So what is the parabola equation? Y squared is equal to 6x. You need which one? Y. So y is equal to what? Square root of 6x. So square root of 6 into square root of x. And 2 to 4, within the limits you have to take y. So this y has to be taken from the circle equation. So what is the circle equation? It is x squared plus y squared is equal to 16. So what is y squared? 16 minus x squared. 16 minus x squared. What is y? Square root of 16 minus x squared. Because this area is above the x-axis. So you can take only the positive symbol. So it is square root of 16 minus x squared into dx. Okay. You see now why this 2 has come. So in the front you are having common 2. So it is applied to both the terms. So first term, for the first term you have written 2. For the second integral you will have the 2. Okay. So see now here root 6 is a constant, it is taken out. So square root of x, what is x power? Half. If you integrate, it is x power half plus 1 divided by half plus 1. So x power 3 by 2 divided by 3 by 2, and the limits varies from 0 to 2. So plus 2 is taken out. So it is in the formula, it is in the form of square root of a squared minus x squared into dx. This formula is x by 2 square root of a squared minus x squared plus a squared by 2 sine inverse of x by a. So using that formula, see the formula. So the formula is integral square root of a squared minus x squared into dx, which is equal to x by 2 square root of a squared minus x squared plus a squared by 2 sine inverse of x by a. So using this formula, in the place of a squared, you will have 16. So it is 4 squared. So in the place of a, you have to substitute 4. So x by 2 square root of 16 minus x squared plus, what is that? A squared by 2. So your a squared is 16. 16 by 2 sine inverse of x by 4. And the limits varies from 2 to 4. Okay. So see now, this 3 by 2 can be written as reciprocated. So it is 2 by 3. So 2 2s are 4. 4 root 6 by 3. So the constant is 4 root 6 by 3. And what is remaining here? X power 3 by 2. So if you apply the upper limit, it is 2 power 3 by 2. Okay. So on the limits varies from 0 to 2. Next step they have applied. And from here, you see the denominator. What is here? From these two terms, 2 is there. So here in the commoner, you will have 2 also. So this 2, after taking these 2 as common, it will be cancelled. So here remaining is x into square root of 16 minus x squared plus 16 into sine inverse of x by 4, and the limits varies from 2 to 4. Now you have to apply the, what is that, upper limit. So your upper limit is, what is that, your upper limit? 2. So if you substitute 2 power 3 by 2, that is 3 by 2 is nothing but 1.5. So therefore it can be written as 2 into root 2. And the lower limit, if you substitute, it is 0. Okay, plus. Now you have to substitute the upper limit. So here you will have 4. In the place of x, if you substitute 4, it is 4 squared 16. 16 minus 16 is 0. So the first term is 0 in the upper limit. Plus 16 into sine inverse of, if in the place of x, if you substitute 4, it is 4 by 4 is 1. So upper limit is over. So minus, you have to substitute the lower limit. So your lower limit is 2. And here it is square root of 16 minus 4. Why it is 4? 2 squared. 2 squared is 4. 16 minus 4 is 12. Plus 16 into sine inverse of 2 by 4. Okay. So see now here, if you multiply 4 2s are 8. Root 6 into root 2 is 12. Root 12 by 3. Plus 16 sine inverse of, in the place of 1 you have to substitute sine pi by 2. And if you apply the minus here, minus 2 root 12. If you apply here minus 16 sine inverse of, here you will have 2 by 4 is 1 by 2. So sine 30 degree is 1 by 2. So sine pi by 6 is written. Okay, so sine 30 degree, that is 1 by 2. And 8 root 12 by 3 minus 2 root 12 plus this term is combined with the first term plus 16 sine inverse sine getting cancelled. Here you will have pi by 2 minus 16 into sine inverse sine getting cancelled. Here pi by 6. So if you take LCM for these two terms, LCM is 3. So 3 2s are 6. 8 root 12 minus 6 root 12 is 2 root 12 by 3. And if you cancel 16, it is 8 pi minus, so when it is divided by 2, 8 pi by 3. So if you take LCM for these two terms, LCM is 3. So here you will have 8 3 so 24. 24 pi minus 8 pi is 16 pi. Okay, so this root 12 can be written as root 4 square root of 4 into 3. Square root of 4 is 2. Already 2 is here. 2 2s are 4. So 4 root 3 divided by 3 plus 16 pi by root 3. From these two terms, 4 by 3 is taken out. If it is taken out from this term, 4 by 3 is taken out, here you will have 4. So 4 pi plus root 3. That is square units. Thank you, students.